Dickinson College's Alliance for Aquatic Resource Monitoring, ALARM, engages volunteers to monitor their local waterways. Using water quality data, communities are able to learn more about the health of their local streams. In this video, we will be performing the alkalinity portion of our water quality monitoring test using the Lamont Kit. Alkalinity is the ability of water to resist acids and changes to its pH. It is mostly determined by the amount of dissolved compounds such as carbonates and bicarbonates present in water. Local geology has the greatest influence on alkalinity. Limestone, which is primarily composed of calcium carbonate, is one of the biggest contributors to alkalinity. To begin this test, you will need to assemble the following equipment from the Lamont Kit: the BCG-MR indicator tablets or solution, depending on what is available to you, Alkalinity Titration Reagent B, the Alkalinity Kit Direct Reading Titrator, a syringe, 2 titration vials and caps, a beaker, the alkalinity endpoint color chart, sample water, and a waste bucket. Once you have gathered your equipment, invert the sample bottle 3 times and rinse the titration vials, beaker, and sample syringe with sample water 3 times. Please note, we do not wash the titrator syringe. Only use a little bit of sample water, but ensure that the water touches all inner parts of the equipment. After you have rinsed your equipment, you are ready to begin your test. Invert the sample bottle 3 times and pour into a beaker, and then use the syringe to draw 5 milliliters of sample water. Please note, if there are air bubbles in the syringe, you must expel them to get an accurate volume. To do this, draw up extra water and turn the syringe upside down, so the opening of the syringe is pointing towards the ceiling, and hold it over the waste bucket. Tap the sides or flick the vial lightly so that the air bubbles float to the top. Now that the air bubbles have been expelled, push out the extra water until the bottom of the cone is level with the 5 milliliter line. Then, add it to the titration vial. Depending on the availability of the BCG-MR indicator, it will either be in tablet or liquid form. If it's in liquid form, invert the dropper bottle 3 times, then slowly add 4 drops of the indicator solution to the titration vial. Make sure you hold the solution bottle vertically when dispensing the solution. If using the tablet form, add 1 indicator tablet into the vial. Once the indicator is added, cap the vial and gently swirl to mix. Be careful when swirling, since the lid of this vial has a hole at the top. The solution will turn blue-green. If you are using the tablet, ensure that the tablet has been fully dissolved before proceeding. Now that the indicator has been added to the sample water, it is time to fill the titrator syringe. First, invert reagent B 3 times. Please be careful, reagent B is an acid, so make sure you take precautions when handling it. Then, insert the titrator syringe into the reagent B cap. Hold the bottle in one hand and the titrator in the other. Invert the bottle. Draw reagent B into the titrator syringe by slowly pulling the plunger to 0 on the titrator. Ensure that the large ring on the plunger is just behind the 0 mark. Remember, if there is an air bubble in the titrator syringe, remove it by gently tapping on the titrator to push the air bubbles to the top. However, instead of expelling into the waste bucket, push the solution back into the reagent bottle to expel the air bubbles and redraw the reagent. Then, turn the bottle over and remove the titrator. Next, insert the titrator into the opening of the titration vial cap. Press on the titrator plunger to slowly dispense reagent B into the titration vial, drop by drop, while gently swirling the vial until the solution turns purple. Please note, you can tell you are nearing the endpoint when the solution gets darker in color. At this point, start slowly dispensing reagent B 1 drop at a time and fully mix the solution between drops. If your solution turns pink or red, the reaction is past the endpoint. Dispose of the sample in the sink with the cold tap running. Rinse your titration vial 3 times with sample water before starting again. Note that your solution may be a darker shade than shown on the color chart, but you are looking for a distinct change from blue-green to purple. To help see the color clearly, looking at the solution with a blank white background and in good light will help. If you use all the reagent in the titrator syringe, you can refill the titrator by following the same process in step 3, but be sure to account for all reagent used when recording your results on your datasheet. Do this by adding 200 mg per liter to the second reading. Now that your titration looks purple in color, meaning your reaction is at the endpoint, you are able to determine the alkalinity reading. Read the titrator scale at the bottom of the large ring, as seen in the picture on screen now. Each line on the scale represents 4 mg per liter. If the ring is in between values, record your average of the two values. For example, if the ring is in between 72 mg per liter and 76 mg per liter, your result would be 74 mg per liter. Please remember, if you refilled your titrator, add 200 mg per liter to your final alkalinity value. For example, if you refilled your titrator once and took the second reading at 74 mg per liter, your result for this would be 274 mg per liter. Empty any remaining reagent B in the titrator back into the reagent B bottle. You've just completed your first replicate. Now, it is time to repeat this process for the second titration vial. Use the sample syringe to draw up sample water, making sure to invert the sample bottle 3 times. Add it to the titration vial. Put in the BCG-MR reagent. Fill the titrator. Add reagent B. And determine the alkalinity reading of your second replicate. Ensure that the values of the 2 replicates fall in the precision range of plus or minus 8 mg per liter with one another. If the values are outside of the range, repeat the test until 2 values are within plus or minus 8 mg per liter. Calculate the average value of the 2 replicates within the precision range of plus or minus 8 mg per liter. Round the average up to the nearest value and record it on your datasheet as milligrams per liter CaCO3. Finally, empty the extra reagent B in the titrator into the reagent B bottle. Place the titrator and reagents back into the Lamont Kit. Once you have completed your replicates, it is time for cleanup and rinsing. Pour the solution from the titrated vials into your waste bucket, as well as any extra sample water in your beaker. Turn on the cold tap as you pour the liquid waste down the drain. For information on how to acid wash your equipment, please check out the video on our YouTube page. Congratulations! You've now completed the alkalinity portion of our water quality monitoring test. We hope this video has been helpful. Alkalinity is an important part of water quality monitoring to protect ecosystems from rapid changes in pH. Thank you for watching and volunteering to assess the health of your stream. We appreciate your investment in your local waterways. Happy monitoring!